Hello everyone, and welcome to the implementation of a graph as an adjacency list lecture. In this lecture, we're going to go over Python programming and how to use it to implement a graph as an adjacency list. In order to do this, you can go ahead and check out the notebook that's underneath the graph folder in the repository. And we're going to be implementing two classes, a Vertex class, and then we'll use that to build out the full graph class. Before we begin building it, let's just go over a few things. What we're going to do is, as I mentioned, create that graph, which holds that master list of vertices, and then the vertex class, which will represent each vertex in the graph. Each vertex is going to use a dictionary to keep track of the vertices to which it's connected to, and the weight of each edge. That dictionary is going to be called connected to, so if you go ahead and scroll down to the code, you can see here we have a self.connected_to empty dictionary object. Then what the constructor is simply going to do is initialize the ID, which is typically just going to be a string, and the connected to dictionary. The add neighbor method is used to add a connection from the vertex to another. We have a get connections method, which returns all the vertices in the adjacency list, as represented by the connected to instance variable, that dictionary we created. Then the get weight method just returns the weight of the edge from this vertex, so the vertex passes a parameter. So with that being said, let's go ahead and build out this vertex and explain what we're doing along the way. It's actually a pretty simple class, and then after that, we'll go ahead and go over the details of the graph class. Let's go ahead and jump to a fresh Jupyter notebook and get started. So I'm going to zoom in a bit here so it's a little easier to see. First thing I'm going to do is say class. Let's just call this vertex. And I'm going to go ahead and say init, pass in self and key. And so the ID of the vertex is going to be that key that we pass. And then as I mentioned before, we're going to have a dictionary called connected to, and we'll initialize that as an empty dictionary. So right off the bat, we create the vertex object. We have a key and an empty dictionary connected to. Now we want a method to add neighbors. So we'll say def add neighbor. That's going to take in self, of course, and then it's going to take a variable nbr for that neighbor, and then a weight, which we'll initialize as 0, so if you forget to put in a weight, it has a weight of 0. And then we'll say self.connected to that neighbor, we create that key, and then say it's equal to weight. So what this connected to dictionary is doing is it's taking in the neighbor as the key, which will be a string, and then the weight as the value for that key. Then what we're going to do is say def, let's say get connections, self, and then we're going to return self.connected to, and we'll return all the keys of that dictionary. So that way we can just grab all the connections for that neighbor, for that connected to dictionary, I should say. Then we'll create couple more methods. We'll say get ID, take in self, and that's just going to return self.id. One more method called get weight. That will take in self and a neighbor, and then we'll go ahead and return that weight. So remember that weight is just the value at that key, so we can essentially just copy that and say return self.connected to at neighbor. Then we're going to add a special method. So this one's going to be that string method. So this is what happens when Python needs a string representation. So it's basically going to be what happens when you say print that vertex object. Python's going to look for that string representation there. And I'm going to say return a string of self.id plus, we'll say connected to, and then we'll say plus, and then what I'm going to do is use list comprehension in order to get a list of everything. So I'll say xid for x in self.connected to. And let's go ahead and zoom out a bit so you can see that whole code. So what I'm saying here is just grab every ID for x in that self.connected to dictionary. All right, so that should be it for our vertex class. We'll check up on it later make sure it works back when we implement the entire graph class. Okay, so up next is the graph class. So in order to implement the graph as an adjacency list, we're going to have the following methods. We're going to have just the graph, which creates a new empty graph. So that's going to be this right here. We'll have add vertex, which adds an instance of vertex to the graph. We'll have add edge, which adds a new directed edge to the graph that connects two vertices. And then we'll also let that same method take in a weight argument if we want to. And that's going to add a new weighted directed edge to the graph. Then we'll have a get vertex and get vertices. This one just gets that particular vertex for that key. And get vertices just returns a list of all the vertices in the graph. And in returns true for a statement of the form vertex in graph if the given vertex is in the graph. False if otherwise. We'll explain that one a little more when we actually get to it. But let's go ahead now and implement this graph class and take advantage of that vertex class we just created. So first thing we're going to do is say class graph. We're going to say initialize it, just take in self. I'm going to say self.vert list, so a list of vertices. It's actually going to be an empty dictionary, not an empty list, and we'll show why later. And then we'll say num vertices is equal to 0, and that will basically be a vertex tracker counter. Next up, what we're going to do is say make a method for adding a vertex to this graph. And so that's going to take in self, but remember, the vertex takes in keys. So what we're going to do is go ahead and add a key to that. We'll say self.num vertices is equal to self.num vertices plus 1. And you could also just say here plus 1. It's up to you. We'll go ahead and go with the shorter methods because it's a little cleaner. But basically that means, so I added a vertex, I need to add a number to the number of vertices I have in my graph. And now let's actually do that. So let's add that vertex. I'm going to create basically a temporary object here called new vertex, set it equal to an instance of the vertex class with that key that's been given. And I will say self.vertList at that key is new vertex. And just keep in mind, the reason I'm calling this list is because we're modeling this as an adjacency list, not because this actual object of the list. So keep in mind that vertList is a dictionary, but the reason it's called list is because we're modeling this after an adjacency list. All right. Then lastly, we're just going to say return new vertex. All right, so that's how we add a vertex. We add a number to our count of vertices, set new vertex object equal to vertex key, say self.vertList at that key is equal to that new vertex object, and then just return the new vertex. Next, I want to get a method for, or create a method for getting vertices. So I'll say get vertex. It's going to say self and n, and it's going to say if n in self.vertList, and keep in mind that if I say in a dictionary, it's going to say in the dictionary key. So let me just go ahead and show you an example of that real quick. If I create a dictionary and I say K1 with a value 1, and if I ask one, or let's say if K1 in D, that dictionary, print in dictionary. But notice if I say this, I don't get anything out because it's not in there. So when you, essentially what I'm trying to say is that when you iterate through a dictionary without specifying dot iter items or iter keys or values or items, etc., it's going to automatically default to the keys. And this is for both Python 2 and Python 3. So when you iterate through a dictionary, by default, if you don't say a specific method, it's going to iterate through those keys. So Why is that important? Because that's basically what we're doing here. We're saying if n is in the keys of that vert list, because that vert list has those keys, which are the vertices in that graph. Okay, so if it's in there, I'm going to return self.vertList of n. Else, I'm just going to return none because it wasn't in there. Next up, I want to say add edge. So if I want to add an edge, I'll say def add edge. Let's go ahead and take a space there. Add edge, and this is where it's going to say self ft cost is 0. So as a reminder, what do these actually stand for? This is going to be the from vertex, or vertex I should say. This is t for to vertex, and then cost is that weight. So continuing on with this, I'm going to say if the f, which is the from vertex, is not in self.vertList, mean we're going to say nv equals, make a variable called nv, set it equal to self.addVertex. And then if the to vertex isn't in there, I'm going to say not in self.vertList. Say nv is equal to self.addVertex at to vertex. And then finally, I'm just going to say self.vertList of f, do the add neighbor method. And let's make sure we spell that correctly, add neighbor. If we scroll back up to our vertex class, we have the add neighbor. So we need to take the neighbor and the weight. So I need to say the neighbor is going to be self.vertList at to vertex. And then that weight is just the cost. So remember, f here is that from vertex, and t here is that to vertex. So here we're checking if they're actually in our vert list. So if they're not, that means kind of we're like adding a new vertex to the graph in order to add that edge. All right, so we're not returning this, we're just setting this inside the actual object. I want to make another method called getVertices, self, and say return self.vertList, and it's just going to go ahead and return the keys. So if I didn't specify keys, I would have accidentally returned the whole dictionary. Now we're going to go ahead and say some special methods here. One is the iter method. So what happens when I actually iterate through this graph object? If I say for blank and graph, in this case, what I want to do is return iter of self.vertList.values. And so what that's essentially doing is it's saying, okay, grab all the values in that vertList dictionary and then make it into an iterable object. So that basically means when I say for object or item in graph, when I actually iterate through it, I'm going to be iterating through the values in that vertList dictionary. And you can check out some more special methods. We're going to add one more called contains. And we'll say self n, and here we'll just return n in self.vertList, and that allows us to use that n in operator. Okay, so I ran that. Let's go ahead and actually check if it ran and make sure we don't have any errors here, because it's quite a bit of code. Might have an error somewhere, but let's go ahead and see if it works. So I'm going to say G is an instance of a graph object. So far so good. And then I'm going to say, let's say for, zoom in here because I zoomed out quite a bit. Let's say for I in range 6, we'll say G dot add vertex of I. So basically just keep adding those numbers. Okay, that worked. So let's go ahead and call the vertex list from it. All right, so we actually have 0 through 5 vertices. So let's go ahead and make sure we can add an edge here. So this is essentially that V0, V1, V2, etc. If you remember back from the presentations in earlier lectures. Let's go ahead and try adding an edge. So I'll say go from vertex 0, so that from vertex, 2, which is that T, to the 1 vertex, and give it a weight of 2. So what is this actually doing? If we go back and check here, if I'm saying add edge, I'm saying my from vertex and my to vertex and that weight. Then I can check if the from and to are in there. If not, I add those vertex. And then I say self vert list, add a neighbor to it. So let's go ahead and check it out, make sure it works. Looks like it did. So I'm going to say now, say for vertex in G, and what does that actually mean for vertex in G? That actually allows me to take advantage of the special methods I created. And I'm going to print vertex. I'm going to say print vertex dot get connections. And then I'll print a new line after that. So let's see if this works. All right, looks like it did. So what is this actually doing? It's going to print the vertex and then print all the connections of that vertex and then print a new line. So remember I have 6 vertices in this adjacency list graph, 0 through 5, and there should only be one connection because I only added one edge. And it's actually here. It says 0 is connected to 1, which is exactly what I had here. So it all worked out. I encourage you to play around with this methods, or with these methods, I should say. Build out your graph a little bigger, but really just understand what's actually happening here in relation to that figure of the adjacency list. That's really all there is to it. So just to review what we did, we created a class vertex. We have add neighbors, get connections, and a bunch of other get weights, get IDs, but really the key here is just set it as a dictionary with a key and say it's connected to weight if we need it. So we have that connected to a dictionary and we can add neighbors to it with weights. So that's the vertex class. And then for the graph class, it takes advantage of the vertex class we just made. So it can add vertices to it with a number of vertices tracker. And we again use a vert list. Again, just to really say this, this is a dictionary, and the reason it's called a list is because it's an adjacency list form. But when we're actually dealing with it, we're working with it as a Python dictionary. It just makes it a lot easier to create this class. Then we can add edges, and everything else is essentially just special tools or methods to work with that graph class as far as getting objects from it, or iterating through it, or checking if it's in something in that class. Okay. That's it. I encourage you to check this out. Again, there's a bunch of notes in case you want to check out all the explanations in the Jupyter Notebook. All right, that's it for the implementation of a graph as an adjacency list. Thanks everyone, and I'll see you at the next lecture.